Some decimals never seem to end. Their digits repeat over and over. 0.3 repeating, 0.72 repeating, and 0.18 repeating are all examples of recurring decimals. Numbers that go on forever in a predictable pattern. A recurring decimal is a decimal number where a pattern of digits repeats endlessly. For instance, 0.16 recurring. The 6 continues forever. Here are some examples of recurring decimals. Notice how each has a bar above the digits that repeat: 0.3, 0.72, and 0.16. These patterns continue forever and never end. Fractions whose denominators contain only the prime factors 2 or 5 give decimals that stop, like 1/2 or 1/4. But if the denominator has any other factor, such as 3, the decimal repeats forever, like 1/3 or 1/6. Here are more examples. 1/7 gives a 6-digit recurring cycle, 142,857 repeating, while 1/9 gives a single repeating digit, 0.1 recurring. To convert a fraction into a decimal, divide the numerator by the denominator. If the remainder starts repeating, the digits in the quotient repeat too. For example, 1 divided by 6 gives 0.166 recurring. For example, 1 divided by 7 gives 0.142857 recurring. The repeating block, or period, has 6 digits. To convert a recurring decimal back into a fraction, use algebra. Let x equal 0.3 recurring. Multiply by 10 to move the repeating part past the decimal, then subtract. You get 9x equals 3. So x equals 1/3. Let x equal 0.7 recurring. Multiply by 10 to move the repeating digit past the decimal point. Then subtract to get 9x equals 7. Finally, divide both sides by 9, giving x equals 7/9. Now let's handle a mixed recurring decimal, where some digits appear once before the repetition starts. Let x equal 0.166 recurring. First multiply by 10, then by 100 to move the repeating section past the decimal. Subtract to get 90x equals 15, so x equals 1/6. Some decimals start with a few digits that appear once before the repetition begins. For example, 0.16 recurring, or 0.12345 recurring. Now, let's take a longer recurring cycle. Let x equal 0.428 recurring. Because 3 digits repeat, we multiply by 1,000. Subtract to get 999x equals 428. So x equals 428 over 999. Let x equal 0.376 recurring. Because 3 digits repeat, multiply by 1,000. Subtract to remove the repeating part, giving 999x equals 376. Therefore, x equals 376 over 999. Here's a decimal where the first digit doesn't repeat, but the next two do. Let x equal 0.123 recurring. Multiply by 10 to move one digit past the decimal, then by 1,000 to move the repeating block. Subtract the two equations to eliminate the recurring part, giving 990x equals 122. So x equals 122 over 990, which simplifies to 61 over 495. A key rule: fractions in simplest form with denominators made only of 2's or 5's produce terminating decimals. Any other denominator leads to a recurring decimal. After converting to a fraction, use your calculator to check that the decimal pattern matches. Students often pick the wrong power of 10, forget to simplify the final fraction, or misidentify which digits actually repeat. We meet recurring decimals in ratio, proportion, probability, and algebraic manipulation. To master recurring decimals, practice converting both ways and check by reversing the process. Keep practicing conversions and you will soon recognize recurring patterns instantly.